Is that working now?
Yeah, it is.
Okay, good.
So Sam's just walking through how to view my feedback on your homework for those of you who are just joining. She clicked on assignment 1. She's clicking on submission details in the upper right-hand corner. And then she's going to click View Feedback, which is adjacent to what would be your PowerPoint or your PDF, which is where I put all my comments for the week. I might have put something in the little add comment box and you saw something short like, great job, or this could have been better, XYZ, see slide for more comments. And this is how you would have accessed those comments. So hers is really slow and we're not going to take the time to wait for it to completely open since we kind of did it before everyone got here. But the view feedback portion, I think, is the odd step that you might not know because it doesn't pop up. So once it loaded, there'll be a scroll bar at the bottom of this rectangle and at the side. You want to scroll all the way to the right. And then you want to scroll up and down to read the comments that are all the way to the right as little word bubbles. Jordan, let me know if that works out for you.
It did. I found it. Thank
Okay,
you.
you're welcome. Yes, I'm a lot of things, but a lazy grader is not one. So as long as we're all able to find it. Okay. So I already started recording through this little portion because I had planned it in, so I'm glad we got it out in these first 2 minutes, which is excellent since the meeting started a little early for questions. Some other housekeeping things. I'll take back the screen from Sam. Thank you, Sam. I have a little Word document. Quizzes. So I do read your emails to me about the quizzes. I don't necessarily answer them right away. I wait until I grade the quizzes all up front. So I wait until I have a couple batches of quizzes because there's so many disconnected emails that I'd be doing a lot more work if I didn't put them all in one large Word document and have, okay, everybody had questions on this quiz. I'll go open it and do 5 or 6 quizzes at once that need to be corrected. So there's people like Brandy and there's people like Sam or Karen who have gotten points back or have prompted me to look at quizzes for other people. So I might have seen Sam's and then put, oh, I need to check Jordan's because she didn't get that same one, and I'm looking for patterns. So you're helping other people when you come to me with questions, right? Now, some cases, it's like there's somebody who's going to support themselves that everybody else got it right, somebody got it wrong, but their reasoning behind it was good enough or their personal initiative to come to me and ask if it was good enough makes me give them back those points. In other cases, and in that case, I just give that one person back. I'm not going to go correct everybody else's, or if there was only one other person who missed it and everyone else got it right, I wouldn't correct that other person's. But if I see this kind of wave of pattern missing where like the whole class misses one whole question, that's a prompt for me to think, okay, something's really wrong with that question. I'm going to go back and look at it. So let me know by email. I've already responded today to a lot of those things, and sometimes I don't get back the points. And in that case, if it was just a true false, I explain why I feel that the book properly answered that question already. But all the points you can get, especially when they're only 10-point quizzes or 5-point quizzes, I'd say it's worth your while to email me if you feel really concerned. PowerPoints in my comments, we just talked about at the beginning. Assignments, if you're missing any assignments, the policy in the syllabus does say that it's 0, but if you know my personal policy, that's a school policy or kind of a policy that's been put into all of the syllabi this semester in our department. But my personal policy is really benevolent, and it's minus 10 points for every week that you're late. And my personal policy, if you talk to me up front, is a little bit differently. So please don't just ghost on me. Don't just not turn something in, and don't email me about why you're not turning it in. If you're struggling through the first assignment, I want to help you. I want to be pretty active and engaged in being your advocate in this class. So I can't help you halfway through, and I've kind of written feedback if I didn't receive something, but I'm receiving other things, asking to meet with people. And I just suggest that you do, because everyone who knows me knows I'm pretty easy to work with, kind of confusing in the way I explain some things sometimes, but more than willing to help. So my other piece of advice is hand drafters that have not met with me as well. I posted the core, the building core, to module 1 of this class. And if you are hand drafting, I'd hope that by the 14th, which is when my other class of Revit is going to have their exterior core walls completely drafted with doors and windows in, you would also have that done. And then every week that I give them an assignment as to how much more to have drawn in for their homework, you will also hand draw. But that means you have to project manage your time. In Revit, I'm watching and they're turning those in for points that they've completed those assignments. For hand drafters in this class, you're just doing it. You're running in the background and getting that done. So if you want more project management on my side because you feel like you're not knowing how to draft, let me know. Okay. Homework 2B. People emailed me kind of frantic today about it popping up. So we talked last week about how it wasn't fair for you to have to do that one because I didn't give a nice example walkthrough of how to use the code books yet. So that won't be due until the 14th. What happened was I physically moved it to module 3. So if you looked at it in the modules, you go, oh yeah, she moved it. But the due date wasn't changed. So it showed up on your calendar, and I apologize for that. We're going to review PowerPoint over chapters 4, 5, and 6 today, which is a lot. So I'll have to breeze through a couple of things, and I'll stop and pause on what I feel is more important. And then we'll review our homework of the door and window focus that will be due next week as well. On top of that homework 2B, I've adjusted that date, so both of those should show up on your calendar. Before I start with the PowerPoint over 4, 5, and 6, I'd rather do the little walkthrough exercise on this so that we can move on with our lives. So I already have the codes book open. The way that I accessed the codes book in order to do 2B was I came into the assignment, which is now located in module 3. I moved it to the week that you'll be working on it in. If you click on assignment 2B, it already has the access to this book embedded in it, and we can access it for free online. It's different than if you had to log into IVCAT and create an account. It's open to the public, so you shouldn't have any problems with it loading and being visible to you. Okay, so with this open, we're just trying to match up the right sections to the actual homework assignment. I created a little Word file of one not related but very similar to the first question on your homework assignment, and to see how we would walk through these things. So it asks you in my question, we have a Best Buy with the maximum allowable, what is the maximum allowable height of that Best Buy, knowing the construction type is type 2 and knowing that it is unsprinklered. So we know Best Buy, and if we were going to do this in reverse order, it would have been, I'd ask you last week, what is the Best Buy in Mishawaka? Can you give me its type of occupancy? And you would have found that it was a mercantile group, M. So we need to know the occupancy first. They're kind of in the order from whence they came. And the chapters on how to read the code books talks about the importance of this order. So first we're finding out the type of occupancy used. If it's a Best Buy, then I know that it's a mercantile type M. The other thing that I know about it, because the question tells me, is it's a construction type 2 and it is unsprinklered. So that's where I have to go into the building codes book, the actual International Building Codes book, in order to find certain graphs and charts and information to tell me what height is maximum allowed for that building. So I put using Chapter 5, Table 504.3, knowing the construction type is type 2 and it's unsprinklered, we can find that it's 65 foot is going to be the answer to this question. So I'll show you how I did that. So first, we already know we can cut how far we're going to need to go. So it's really helpful looking at the chapter titles to know which chapter you're going to go to. They're all accessible to you. Use and occupancy classification, step 1. I figured what that was. Chapter 4 is just tied to use and occupancy classification. So it's special and detailed requirements based on those, but it's not telling us anything new. It's just, okay, here's a special case that's not a nicely and neatly fit into mercantile group type M. It has something extra, like there's an extra kitchen within a Best Buy, which makes it kind of a double use, and it has this. So these two kind of go together and are considered part of occupancy. Then we have general building heights and areas in Chapter 5. We have charts for types of construction in Chapter 6 more specifically. So let's go into Chapter 5 and see what that has for us. And just by doing the down arrow and selecting, you wait a second, it reloads and it moves you to that chapter. So I want to know the maximum allowable height. So I see there's sections, and without reading all the information, and you don't even necessarily always need to read, you might go backwards from the charts, but we're looking for key charts this week for most of the information at the first couple of questions, and then some of this detailed information later. So general building height and area limitations. It talks a little bit specifically about type 1. So let's look at our question and make sure we don't need to have any red flags. So it's type 2 construction and it's unsprinkled. So I can just kind of skip over that visually, maybe come back to that if I have another question that's type 1. I saw a little flag there. Building height and number of stories. So here I have a nice neat table that's labeled allowable building height in feet above grade plane. Grade plane, as we learned from actually this chapter this week, starting in 4, I believe, grade plane is just, we can think of the absolute ground level. Sometimes we consider grade, they put a little bit of a membrane underneath the actual grading, but if you think of your site plan, it's dirt top level of the ground. So from grade up, what do we have? So we have to kind of start over here and move over in the chart, just like we start with occupancy in our book and move over by our not sprinklered and type of construction. So we then want to look for our M, which a good deal of our categories seem to fall right here at the beginning, right? It seems more like big special things like institutional might be down here, but A, B, E, F, M, S. So assembly, we have mercantile, we have business. Those are like the big guys that we're really dealing with. They're right here at the front. So I'm okay, this is where I start. We have not sprinklered and sprinklered. So again, you can always refer back to your question. It's type 2 and it's unsprinklered or not sprinklered. So I am right here, not sprinklered, and then type 2, and it's 65. So nothing changes in this situation, whether it's not sprinklered or sprinklered. Oh, sorry, I came down. Oh, it does. Sorry, I jumped my eyes. M, not sprinklered, there we go. And then type 2 construction, so I come to this part, and then it says maximum height. So in that case, the maximum, there's two options, A and B. My maximum height would be 65. There might be some questions that ask you something. Is it A, looking specifically at A, what is the value? And in that case, it'll be spelled out in the question. So I know it's M, not sprinklered, so I come up to this level, I drag over to type 2 construction, and I find the highest value, which is 65. Does that make sense to you? Based off of the question?
Yes.
Okay, great. So a lot of them, like I said, are going to be based off of these main charts in here, which we find under Chapter 5. And now that I've taken the time to organize my thoughts, I'm showing you how you'd walk through it step by step. And I've showed you more about how you would understand the specific codes and what to look at. So occupancy 3 and 4 together. And then this is where our major types of heights and areas are with the charts. And then any specifics on types of construction. And then if you were to have a question about possibly fire safety or allowable areas for fire prevention, you might look for buzzwords, right? Or protection systems, means of egress. Those kind of buzzwords will be within the questions themselves. So you would go to those chapters, and then most of the time we'll have a nice chart, or it'll be grouped by your occupancy. So it'll say M, and then under these things you'll find M under means of egress and go straight to the section associated with your occupancy. So it seems a little daunting, but it seems really easy once I break down one full question to you. I think it would just be awful if I wouldn't have gone through this today. So let's imagine we have another question, and it says, what is the maximum allowable stories above grade plane for an occupancy A? If it's sprinklered, then it's type 1. In that case, we'd go, okay, I have A, well, and it'll probably be even more specific, right? So A1, 2, 3, 4, 5. Those things are based off of the occupancy, so you could go back and maybe if it was assembly, like a church of a special type, and that happened to be A5, okay, well then it's specifically A5, and then it's sprinklered or not sprinklered, the type, so on and so forth. But the buzzwords will always be referring back to the table name. We have mezzanines and equipment platforms. Here we have allowable area in square feet. So what is the highest allowable area given those same kind of requirements? So there's a couple charts in here, but really the majority of your answers are going to come from 5. Now there's going to be at least 2 or 3 questions where you might need to do some Google searching to answer the question. I walked through this, I remember, after doing it last year with some students. And some questions about framing won't be easy to find. But just give it your best shot, and we'll see if we can find the information or we can't. And if we can't, and it's an overwhelming can't, then we don't count the question. Okay? Okay, so just walk through the questions. This should be helpful. And I'm going to move on to the PowerPoint. I'm going to check the chat really quick. Doesn't look like that got updated. So no worries. It's just a lot of text, but it's very well organized. Okay, so I'm going to open up my PowerPoint. My long PowerPoint because it's 3 chapters. And then I will click my Make It Big button and start presenting. So, actually, 1 second. There's an error on my side where I can't see my own screen. I'm going to stop sharing my screen for a second and pause. All right, dead load versus live load. So dead load is basically all of the pressures that we're seeing coming down vertically from a top that are part of the structure of the actual building. It's equipment also that's attached and is pulling down vertically. Anything that is going to stay with the house, this is an easy way to think about it. If you were to move out of the house, it's going to stay physically attached to the building. So that includes kitchen cabinets, anything attached, drilled into the wall that's going to stay, things like water heaters, things that just can't be removed for the house to function for the next user. Those are what's causing our dead load. As opposed to our live load, which is shown on the right in blue within the house, which could be occupants, furniture, and anything that you're storing in the attic or could be removed when you are, in fact, ready to move. It changes over time. And another thing not shown in this picture, so we do want to consider things like snowfall, right? We have a lot of that around here, or at least where I'm at. And then even rain, if it accumulates in the right way, are adding to our live load. It's constantly in that state of changing. Superstructure is the building's vertical extension above the ground. So that would be this guy right in here is the superstructure. And then we have everything that's supporting underneath it. But it would not include the actual footing of the basement within the superstructure. Here we have some pictures of the terms that were mentioned before. So we're showing beams, vaults, and lintels. Absolutely not showing the full extent of vaults. If you've taken history with me, then you would have learned about these things already in some greater detail and seen them in some historic buildings. Our vaults that being shown right there is a barrel vault. Our beam at the top is a horizontal structure member that's longer than it really is wide or deep, is how we think about a beam. And then lintels, I'm showing two pictures, although they're kind of funny in how I'm showing them. Here in the upper left-hand corner, we show the lintel from what it looks like, just plain, maybe decorative on the outside of a building. And we might not consider that on the inside, here's what's happening. The lintel could be a reinforced metal piece like this that runs horizontally, or it could be wood that's behind the actual existing face of the brick that's helping to span the load for our window openings and our door openings. It's just reinforcing it so that it doesn't crack or wear. Here I am showing you all a bunch of different truss styles. So we have built-up beam that utilizes the inherently stability properties of a triangle in order to spread the load. So the triangle is the main defining shape of all of the trusses. Up here we see a pretty simple king post, and it can be as complex as the bowstring, but there's plenty of options to be used in our architecture. Here, and I kind of uncompleted it because I was working on these slides today and I wanted to add in some narrative, but we're looking at cantilevered buildings and it looks really unbalanced and like it's about to fall off, but the way that a cantilever functions, it's just fine. And some of these buildings, they have used some very complex math to balance that and a balance of materials. So at the back we see a supporting masonry item, which would most likely be concrete masonry units fully, like this full thickness would be filled, which would help balance out the weight of the cantilevering glass portion of it that's on the grid system of steel. But usually, so sometimes it is that they've done the complex math to balance it and this isn't balanced back here. It just has to do with the base balance. But sometimes it's just the material is heavier at the back in order to support the lighter steel framing at the front. That's what I wanted to get at. And below that, this little baby picture, I was just going to say Frank Lloyd Wright is one of our #1 users of the cantilever method in order to create fun architecture. And I was going to fill in like 5 or 6 more pieces, but I just never got to it. So now we're looking at our vertical supports. Vertical supports include our pillars and posts, columns, and load-bearing wall. There's some interesting verbiage within your book this week because they talk about how you would define a post, and I don't think it's even going to be what you were expecting. So the only difference between a pillar and a column, for instance, is the attachment. A pillar might be detached and considered a monument, so we give it a different terminology, but a column is almost always attached. And maybe you thought for a while it was the other way around for those two. Or a post, we have a wooden column that's made from one unified tree trunk. That's what truly a post is considered. So we might have thought it was a different architectural member, but it's more about the content of how it was created than really about defining it out as its own separate thing. We're also going to look at shear walls, which is the lower left-hand corner. What is a shear wall? So it's this guy, we see RC shear wall, that's running the entire vertical length of the building, so from top to bottom and coming into the ground. And it's taking the force of the shifting and in some cases twisting that happens in certain environments. It goes through the full building height, which is different than individual framing members that we see from floor to floor, stopping in between the ceiling and floor assemblies. So on the right-hand side, I just did a picture of load and non-load bearing walls. So at the top, we're showing the roof truss and the triangles that make up that component. Then we have a non-bearing wall, which can be placed anywhere in the space because of our load-bearing walls, which are at the center, and they are making sure that we're equally balancing out the load that's caused by our ceiling and floor assemblies and the overall superstructure of the building pulling down at that vertical load. So our non-load bearing walls are the things as interior designers that we have a lot more say over, right? Because the contractors figure out the load bearing walls, he'll just say, these are the walls you can't move, and these are the ones that can be decoratively placed to subdivide spaces as bigger or larger as we see fit. We have bearing beams at the base, which could be concrete or steel, and then we have columns, which sometimes are metal or concrete as well, and then older buildings are still brick. Here's just some pictures of examples of showing different types of columns. We have wood columns, an example from Saratoga Springs, New York. Cast iron columns from Saratoga Springs, New York. Sorry, I'm tripping over them. Masonry pilasters that are exposed on an interior of a building and are very much popular right now. We have lateral and shearing forces, looking at grid frameworks, as well as looking at our service cores. So when we're looking at lateral forces, we can think of things from history like our buttresses and our old church that are helping to support things throughout its whole lateral center, or possibly a cross wall, which I'm not showing here, but I will show in a later slide. I'm showing kind of a blurry image in the middle here, but it just gives the content of the book on what is tension, compression, shear, and torsion as it relates to shape and construction. So tension is where we have two sides pulling against each other as if they're going to rip from the center if something's going wrong. Compression is where you're getting too much force from both the bottom and the top, almost a crushing motion. Our shearing is where it's shifting so that it's going to separate at its center in opposite directions. And then tension or torque is where we're getting the turning and twisting, which we might have in a high-rise building of a really light steel, but we also have modern conveniences and technology that has accounted for that in our certain material usage. All right, so the images that I'm showing at the bottom is our picture of an open grid work. So shearing is where it's moving that side to side, and sometimes it's twisting, but it can be resolved by our brace frame, which is this red guy right here. We see it's the inverted triangle within a rectangle, and sometimes it's partially exposed, so you won't see it would be back here behind the wall or under the subflooring and then into the ceiling. But these are the same things. You might have seen them in some cityscape buildings. And then up here, I just have an example of the inner grid work that's created by our steel framing, from which everything can be placed for the overall interior of the building. Because we have frames like this, we can get to those larger expanses where we don't have to use light wood construction, and we can have big open rectangles without so many load-bearing walls in between because of the strength of those I-beams and post supports from the steel framing and the grid work. All right, our service core. We talk a lot about this in other classes, so I'm not going to really harp on it that much. It's just an area in most multi-story buildings that groups together the stairs, elevators, toilets, rooms, and supply closets. It's really interesting. We'll talk about it in history. Here we're showing it at the center, and it's mostly what we have now, especially in cities, right? It provides for the smallest footprint. So you put all of your workable, livable space on the exterior, put all your elevators at the center, as well as maybe your housekeeping and localized bathrooms. And that way, everything on the exterior is consistent. So most consistent, smallest footprint. But then you might have another designer who believes that all the living should be at the center, and then you want to vary those areas at the four corners. There's lots of different ideologies that have gone along with it, but we know that certain spaces do work well together. And this is also the most energy efficient because we're putting all that electrical into one spot and plumbing, as opposed to picking a bunch of different exterior plumbing walls, separating it out, and causing more cost to be built into the project. To the left, I'm just showing an example of a side cutout view of our service core as it goes to each of the floors, just for a fun added visual. So I wanted to add another visual so we can think about how walls are built, since we're dealing with building systems as a whole. I think people get really freaked out by wall sections when I make them do them in all my classes. So just remember, it's pretty simple. With the floor joists at the bottom, it's just wood, a subflooring material. On top of that floor, so this is the floor in this case, right? If you have a hardwood, it might just run right over top those joists. We might carpet over the hardwood or plywood boards if we don't have hardwood existing, or tile over that, right? So it's pretty simple to draw the floor cutout of this section. So the exterior, we'd have studs, and then atop our studs, we would have some thickness of drywall. And then going towards the outside, we'd probably have a layer of insulation between these studs, and then possibly we would have a protective layer and then our siding. And then at the top, we simply have drywall, more joists, depending on how many floors we have above, or this could be the planum in which we might have joists at a different spacing with an attic above and kind of a truss. And then here it's showing a concrete wall, so who knows what this goes to. It might go to some type of exterior garage that's really, really cold, and so we're not just going to have basic drywall, or it might be attached to something special. But when we look at cut-throughs like this, and we can see them three-dimensionally, this is a lot less daunting and scary, I think, than when we look at some of the black and white drawings that we might have seen earlier in this PowerPoint. So structural types, I've talked a little bit about light frame structures, and I've used buzzwords like light wood framing, light steel framing. What does that look like if we cut through and look inside some of these buildings? So the first one actually is light steel framing, and that's where the size of the steel pieces, they're hollowed out. Actually, they have little chambers or rivets cut into them at varying depths and spacings, so that they're as light as our wood construction, but more durable, and maybe not exactly as light, and in some cases lighter. So it's just about how hollow that member actually is. But you can tell from the silver that it is metal. And then below that one, I am showing my post and beam heavy timber. And this construction, you can just tell from the thickness. That's all you really need to have to intuit that it is heavy timber versus light wood construction, which was shown on my previous slide, right? I just have 2x4s, and I might have a double one for the header to support my frame of my door at some points. But most of the time, it's not going to be as thick as post and beam heavy timber. Below that, I have pole construction. So it's a type of wood construction where it's more of this ladder formation, more of a grid work, instead of the full ballooning light wood framing. And we'll look at what ballooning means later too. So here's just a framing model. This one's more of our post. Here's a balloon framing. So that's just, balloon framing is where we have the first wall that I was showing in that three-dimensional cutout where the ladder is uneven. It was kind of a perfect ladder when we look at the pole construction. If we go back, and this is an interior, but the idea that we have a top member, a bottom member, and then every so often we have our 2x4 studs that runs in between, and then we're going to have to spread the load by having our blocking horizontal supports. That's what we're looking at within the interior of our balloon framing, using the wood to support it in that very simple pattern. We have the roof. We might have a double plate, and then our subflooring where the fire stops, and then some type of vertical member, mostly wood, and continuing that pattern all the way down. So masonry structures, it's going to go through a whole load of masonry structures in our book. Masonry wall construction, masonry open, movement joints, what's stone masonry, brick masonry, concrete masonry units, glass block units, and unfired earth constructions. I think of all of these, you'll be pretty familiar with them just from life, but possibly the most new will be that unfired earth construction. So what it's talking about when it mentions movement joints are breaks in construction that are incorporated into a masonry wall in order to control the movement easier. And we have expansion joints that are designed to close slightly when mason materials expand, and control joints, which are constructed to open slightly as concrete masonry shrinks. So they've added special types of joints to these constructions that allow for heat and cold. They allow for the contracting and expanding of the joints. We have rammed earth construction, which I'm just bringing up because I talked about the fire construction, and I'm showing a picture of it in the lower right. So unfired stabilized earth technologies allow for stiff mixture of clay, silt, sand, and water to be kind of compressed down, and then it gets dried within wall forms to give us that really beautiful form that we see on the right in the red. Oh, I just wanted to go back. So here, I did mention here I'm showing our stone masonry. Below it, I'm showing our brick masonry. And sometimes we have brick masonry where there might be the lintels built into it, and we're starting to see it could also be purely decorative, like this picture. It's not always structural. There's not always a lintel above a support. They might have a 2x4 running the whole expanse, in which case they wouldn't need it. And then concrete masonry, and then the unfired earth. Brick construction. So here they're just showing you the cutout of how that works. So the stacking of the bricks. We always have a row of bricks, then a mortar bed, then another row of bricks, but in between each of them is where we'd have these wall ties. And then when the mortar dries, the wall ties help to kind of build this infrastructure between the bricks. It's what's going behind in the background, if you will, that we can't see, so that they have more support together. Glass block wall, we're probably all pretty familiar with. And then within your book, you're going to have common building stone types. So we have granite, which is a very hard, strong, durable, weathering and abrasion resistant. We have marble, which is high compressive strength, most durable in dry climates or where protected from precipitation. There's limestone, which is softer and more porous than granite and becomes harder when exposed to weather. Durability, greatness in dry climates. We have sandstone, which is highly porous, easy to work with, but relatively low in durability. And then there's slate, which splits into slabs easily and is extremely durable, but I also want to say it is extremely heavy. So, moving on, we're looking more in depth at some of those concrete structures, cast in place concrete versus tilt up construction versus precast concrete. So I'm showing them in the order of which they're mentioned from left to right in the images. So cast in place is where they've already set up the metal grid work and they're pouring it into the cast. They're making a cast of the concrete to make a floor or a wall. Tilt up construction, I thought the image does it justice, right? They just bring the giant sheets of the pre-constructed concrete structures there, and then they use cranes in order to pull them up on site. And precast is where we have moldings of them in which they've been poured on a different location and they click lock together. And instead of being full walls, it's smaller units and pieces. So if I was going to talk a little bit more about the processes, we'd say cast in place concrete is cast into formwork where it's used by a concrete mixer or aggregator truck. The tilt-up construction technique consists of a reinforced concrete walls that are directly on the floor slab, and the slab's in place first, and then with formwork, they're tilted up by the crane. And then precast is structural elements cast, and the seam is cured off-site so that they can have more of a controlled condition. They're transported to the site and then set in place with cranes as well. So they show us one of those joints that we talked about earlier. Here's a physical example of a concrete expansion joint. So we can see the seaming between the two pieces. Concrete additives, we have air entraining agent, which disperses tiny air bubbles into concrete or mortar mix and improves workability, produces lightweight insulating concrete. We have accelerator, which increases the rate of setting and strength of development of our concrete. A retarder that slows setting to allow more time for working. A surface active agent, which helps water wet and penetrate the mix and aids in distributing other additives. A water reducing agent, which reduces the amount of water required to keep the concrete workable and generally increasing the concrete strength. And then color agent, which is allowing for pigment or dye to alter the concrete color. There's pre-cast, pre-stressed concrete structural elements such as solid flat slabs, which we kind of showed in the prior picture with the holes on the ends, planks used for short spans, uniformly distributed loads, hollow core slabs, planks with hollow cores to reduce weight, uniformly distribute loads over medium to long spans, single and double T's, which are T-shaped planks with single or double stem for a broad flat slab, and a ledger beam, L or inverted T-shape beam with projecting ledges to support the ends of joints or slabs. All right, and then it just gives us some of the nominal sizes of our columns, and we can move on to metal structures. So when we're looking at the different variety of metal used, things we would experience would be cast iron and wrought iron, as well as steel framing. So cast iron is a bit brittle. It's an iron-based alloy that contains carbon and small amounts of silicon. It's usually cast in a mold and then machined to make a building and different ornamental products. I'm actually showing cast iron right here so you can see kind of the bumpier texture. And then we also have wrought iron, which is tough and malleable and relatively soft. More soft definitely than cast iron, but it's suitable for forging and rolling, and we might see it in even more workable decorative work like this gate being shown on the right. And then steel framing I'm showing in the picture below that. And we talked about it earlier. And there you see the I-beam. They call it I because we have the wider flange at the top and bottom with the skinny middle part. So in profile, it does in fact look like an I. On the next slide, this is me again, just reminiscing about my favorite part of history. And if you've had that class, then you know it's the Crystal Palace. And it was one of the biggest interiors. Well, it's not just an interior show, but it was one of the great feats, almost another wonder of the world until it burned down. It's made completely out of cast iron, and this was before they had figured out how to use steel in order to have giant structures like this. So it was made of hundreds, if not thousands, of small pieces of glass that were already framed in cast iron, brought to the location and then stacked together. So they were kind of prefab and then locked into place. But for the time, it was pretty awesome. And you can just see what it was like in color in the lower right-hand corner. It did burn down, which is so sad. They had exhibits on every time period up to date. They had all types of stuff, scientific discoveries. They had the light bulb that was on display there at the time. So sample structural steel.
What burned if it's made of glass and iron?
Oh my gosh. It's really funny because the book, our history book doesn't say how it burned. But then Mary Hart, looked up, like she looked it up while we were doing our session and figured out how it burned. And I don't remember, Heather, but I think it was something benign. Like all the materials within it could. So you're saying like, how did it melt? It got to a high enough heated point from the exterior and the interior materials burning that it started to melt the glass. The glass wasn't the same quality that it was today. So the glass began to melt and crack first, and then it kind of imploded from there. But I don't remember what it was, but it had nothing to do with the actual venue itself. It was something like somebody brought in, and it was really ridiculous, but I can't remember. All right. So we have sample structure steel forms. We have a W-shaped wide flange, which H-shaped form with wide parallel flanges used both for beams and columns. We have the S-shaped American Standard beam, an I-shaped section with sloped inner flange surfaces. And don't ask me why they want to confuse your names with the shapes. American Standard channel, rectangular C-shaped section with sloped inner flange surfaces. We have an angle or L-shaped section with equal unequal lengths and pair of angles, and so on and so forth. The one we're most familiar with is the American Standard beam, the I-shaped section with sloped inner flanged surfaces. And then also at the bottom, we see quite a few of the open web steel joist bar joists, the lightweight steel joist supported by the upper cord webbed with often zigzag steel bar. And we'll look at a few configurations of types of steel structures later in the PowerPoint. Oh, here it is. It's later. Get ready. So other structural types: shell structures, cable structures, membrane structures, and mixed structural types. So a shell structure is basically a thin curved plate structure that's designed to transmit applied forces by compression, tension, and shear. So it looks at how to balance those forces using the plates, and it's showed in the first image on the left. So they're doing kind of the anatomy of these triangular shapes like a truss, basically, and then looking at the materials that bind them together and the angles that they're curving them in order to control all those forces and make it the most durable. And then we have in the middle, we're showing an example of our cable structure, which is pretty self-explanatory. We can see the mechanisms of cables connecting to each other. And then maybe unfamiliar to you, has anyone seen a membrane structure in person? I haven't. I've done so little travel, it's not even funny, but a thin, flexible surface that transmits the load along lines of tensile stress. So just like a tent, right? Very simply, it's like a tent. And it can be made of all types of materials that are tent-like, more fabric, or what is the word that I'm looking for? Fiber base.
Isn't this along like don't they use that to put salt for the structures for salt for the roads?
Oh, along the toll road?
Like that. Yeah. Mm-hmm.
Maybe you're right. Yeah, I think you are right now that you mention it. Maybe I've seen it. They're just not as fancy, so I'm never drawn to them, and they're snapped into my memory like they should be. They're nothing like this image on the right. Yeah, exactly. But good point. Concrete and brick buildings. So this is just showing a mixture of those two things together. We've seen plenty now. This is probably one of the oldest photos we could have picked. Membrane structure types, since that is one of the newer things to us. There's the tent structure, which is the best way to think of it to burn it in your memory. So we have the pre-stressed by external forces, completely taut under all anticipated load conditions, usually a sharply curved in opposite directions. A net structure, so a surface of closely spaced cables rather than fabric material. And then air-supported structure, a single membrane supported by internal air pressure, anchored and sealed along the perimeter. So like when you did the parachute exercises when you were children, and then the parachute stayed up when you quickly pulled it down. Air-inflated structure, a double membrane structure supported by pressurized air within building elements. And then we just have an interior picture of a tent structure in Denver International Airport. Which brings us then to our next chapter, Chapter 5, Floor, Ceiling Assemblies, Walls, and Stairs. So our knowledge areas for this chapter are how the depth of the floor ceiling assembly affects the height from the interior ceiling to floor and the total building height, how floor systems affect the work of the interior designer, introduces floating floors and accessing floor systems, introduces design considerations for stairs, ramps, and exit stairs. So first they'll give you an introduction, and then they'll talk about specifically horizontal structural units, floor ceiling assemblies, floor functions, floor ceiling assembly composition, exposed ceilings between the floors and ceilings, and lastly, interior design concerns. When they're going to talk about the floor and ceiling assembly, they're just describing how the floor and ceiling are built. I know that seems simple, but I want us to get us all on the same page. It's acting as a support, a fire control, if you will, between floors, a thermal control, this is the floor, sound control, it controls privacy, and it controls comfortability. And what I mean by comfortability isn't as simple as, oh, it's, you know, soft, luxurious fibers. It's, in some certain situations, there's very premier flooring that has been created so that people are optimized in what they do, like nursing stations. There's very specific rubberized floors, and now they have even carpet tiles with specific backgrounds on, or back sidings for those, that have just the right amount of bounce for somebody who's on their feet for that many hours. It wouldn't be necessary in a normal office situation, but it's been created for that field of work. So if you look, especially on our building assignment, when we get deeper into materials specifically, you might want to look at what your employees are doing during the day, and Google if there's any special materials for that job. And it's not always just in the healthcare field. There's special type of business functions as well. So we also have it being a barrier for water, humidity. It acts as a shield in certain situations and climates where we buy a special type of flooring because it locks it down and pushes it underneath the slab as opposed to letting it out, and it prevents the slab from cracking. It kind of balances it out. And then the ceiling controls radiation and air temperature that would be coming down through the roof, which is easy enough to think about. It also acts as a humidity barrier, is very specific in how we control fire within the space. It helps with visual and acoustic privacy and allows us to adjust the movement of our overall structure and supports the overall structure. So a lot of that built-in truss work and how it connects to the superstructure is going to, in earthquakes, any type of wind condition, we've taken all of that account into the architecture so that we're going to be safe. I won't bore you with my white slide anymore. Planum. So here's just a nice picture, another 3D cutout. I'm going to try and use as many of these as I can to communicate ideas. The planum we're seeing at the center here, labeled as planum, that's predominantly our HVAC space, right? And then above the planum, we might have an environmental airspace, which only the planum rated products, cables, raceways are permitted within the environmental airspace. It's kind of like a free gap that only allows for those materials. We have a suspended ceiling. If we were at Ivy Tech or many places, we'll see these being 2x4 troffer lay-in tiles. We have our return air, and we have our diffusers. And we will touch on those next week because that's when we're going to encounter HVAC. And I'll have you do an exercise with looking at a space and figuring out measurements between these before I tell you the specific measurements myself. We have a raised floor. That's what they're calling it in this situation. It's raised, but it's not necessarily accessed. From the picture, doesn't show it's very well accessed. We don't see the cracks in order to get down to it. So sometimes it's just raised with no access. The access might be in the space adjacent to this space. Here we're showing an exposed ceiling. I feel like I skipped a slide, but interesting enough, your book is going to explain that in order to be in code compliance, while we might see in apartments in New York or Chicago, they're going more and more to this exposed ceiling for that urban feel. The cost to take away that ceiling planum division of just the ceiling tile or a gypsum board and get that look and then spray so that it's health code, because we don't want types of dust and mold and humidity to form up here, that protective layer is removed, and it's actually there for a reason. So they have to coat it in a special type of foam or other material to protect it. And then wires have to be so much more protected because they don't have the protection from the ceiling. So the cost pretty much is a wash, if not more expensive, to do something like this. But originally, the expectation was, oh, I'm cutting material out, so I'm going to be saving money. And over time, the codes have developed along with that idea, and they said, oh, I'm sorry, it's become more dangerous, so no, which I thought was kind of funny. I want to go back, though, because I feel like I skipped over a really nice detailed slide of our floors and ceiling assembly composition. So again, we want to think about how all the materials go together. So here we're seeing those joists that we saw earlier, and then we might have a subfloor. And then below that, we're seeing this is the floor below. So imagine this is level 1, and then this is the floor of level 2. Okay, so you've got to get used to kind of intuiting that. I know I put the picture in, so you're like, of course you know what it is, but I would know it without all the labels. So we have our 5/8 inch drywall, which signifies to me, this isn't on top of the ground level. This isn't grade. And then we have green glue. Then we have another layer of drywall, which could be for some sound protection, or it could be product specific as to why they did a double layer. We have clips and a channel system, which help to lock in our floor joists above the ceiling and hold up then support the material, and it be tied into the metal grid of the overall infrastructure of the building. And then we have the floor ceiling joists, a soundproof rated insulation, because we don't want the stompers up here to stomp, and then these people get really angry below. Urethane underlaying adhesive. So think about it from the ground floor up. When I give you that assignment many weeks from now, remember that we went through this and it's a resource to you. Write it down in your notes. A wood frame floor assembly. This is where I said it's easier to look at things like this. What I'm going to ask you for is something like this or something like this. And I think these black and white detailed drawings on things like this where they're showing an interior cut are scary. So we have the strip wood flooring glue, blind nail to plywood subfloor, urethane-based adhesives. Once we're more into our cross-hatching and we're using just line weights to delineate those things, it becomes a little bit visually confusing. Like we might memorize certain things are, like most often, even though, let me look at my call out to if it even shows it. Well, this curly pattern in the background is usually used for insulation. And then when we have our sideways dashing right here, that usually does signify to me a plywood subfloor, versus if I was going to have a gypsum or a concrete, which is going to be the dotted pattern. So start paying attention to the patterns used, because it will help you in your drawings and your interpreting as we move on in other chapters. That insulation, see, I told you, curly pattern. All right, so we keep moving forward. Wall systems. So we have load-bearing walls and frames, and we kind of look at how they're distributing weight in an earlier slide. We saw usually the load-bearing, it showed it right center in the middle. You might not need one in the middle, but if you don't have one in the middle, you'd need two on either end, kind of like 1/4 of the way in from both sides, because you moved that nice central one, which was evenly splitting the load. So it might be better to have it at the middle unless the space is so small that you're cutting it into a non-usable space. We have load-bearing walls that are predominantly, not only are they centralized or dividing it up into equal portions, but they're mostly made out of concrete masonry, and they're usually at least reinforced with metal or doubled up. So we have them being pretty strong against the things that we were talking about earlier, like tensile strength and compression issues. Openings such as windows and doors are going to have big impacts on the load of the structure. That's why we saw the lintel before, but it also has an impact on what type of materials are used and how we can reinforce them outside of something like a lintel. So I've showed a picture on here where we have, these are called, this is fun to say, double studded staggered construction in the lower right hand corner. And it's great for sound control and load because they're staggering those 2x4s, right? We see one forward, one back, and then there it seems almost extra. Whereas usually we might just have this first row or just the back row centered. So they're staggering them left to right, forward and back. But you can kind of intuit that the bad news would be if we have pipes or wiring or anything that needs to run through a nice clean channel, we don't have the strength of, say, like a pipe that would usually be, like you'd usually have these two things touching each other side by side for the reinforcement. The pipe, we don't want to have to bend pipe back and forth, nor do we want to have to cut and grommet holes for all of our wiring that way. So it adds a bunch of cost that way. And this is another thing where it's a wash. They've tried to use it to help with structure, but in the end, and with sound, but in the end, the cost to just maybe add some type of acoustical treatment on the outside of the wall to help out, it was a wash. So pay attention when you're doing your homework assignment and I say, okay, tell me something interesting you learn and do more research into it as how you're going to do the construction of your building this week. And you say, oh, I'm going to use staggered, double staggered studded construction. And then I say, well, you know, is it necessary? You know, so don't just go with the new. The new isn't always the best, but that doesn't mean it's not. If you're going to do something where it's like, well, we found out this isn't the best way to go. I mean, exposed ceiling might be perfect for some of the businesses that you've picked. Like, you could make a really tailored urban look. But if you're going to do it, then I want the positives and the negatives. I'm always looking for true research, not one-sided research that's just opinion-based. Oh, we missed the previous slide, Karen. We cannot miss a slide. What time do we have got? We still got a half an hour. We want to go backwards. All right, so floor systems. We missed a slide: concrete slabs, wood floor systems, steel floor systems, floating floors, and access floors. So access floors is this, where it could be metal tiles, actual ceramic tiles, and wood tiles, but they're over a metal post system where we can remove the individual tiles to have access below to our wiring, mechanicals, and plumbing, anything we'd want. We might see these in education areas. A lot of times we will see them in mechanical rooms, like an IT situation, or on the other side of the wall we have a bunch of computers operating and then they want to have a kind of a mainframe in the backspace. They'd have way more wires than they'd want to see publicly at the top of the room. So to keep cleanliness in line, they'll put this kind of a floor in. In the upper right we have a floating floor, and you can see just the little tabs running under those. So it's where they don't sit directly on the slab, they're floating above it and then locking together. You'll see a lot of that at Lowe's and Home Depot and options nowadays, where it's just quick lock floating floor. And it does really good. A floating floor is good for unevenness. If there's some type of problem with your floor slanting in spots, then the floating floor moves kind of with those uneven properties. Whereas if you put tiles straight down, it'd be inclined to crack once you glued it straight to the slab. And then below that we have steel floor systems, which are usually like this mesh, or maybe a series of tile, but mostly they are a mesh like this. Sound control existing walls. Stairs and ramps. So stairs, stair codes, risers, treads, nosing, so on and so forth, because we're going to read a little bit more about this. This is just the intro slide. These are good chapters for your life. So if you're 2 years here and that's it, even if you're going to go on to 4 years, in every class and in your capstone class of advanced, you're going to want to hold on to certain portions of the chapters of the book. And I've kind of called them out in slides to follow, where it just kind of consolidates all of the codes that are associated with stairs and ramps and ADA accessibility, and puts them into easy verbiage with pictures in the book that we have, and then it references back to where it came from. So I like that because we have kind of like we had our codes interpreting book before this week, before we got into the International Building Code. It helps give us a reference point that we can easily understand, but it also gives us the original source of the content. So you're going to want to bookmark these and save these books, or photocopy just these pages. Not all of you save your books, you go on to sell them. Tear, I'm crying when I say that because I save all of my books. So staircase anatomy, this is just something we want to commit to memory eventually, right? The newel is the green portion here. We have a handrail, a baluster. When we have multiple balusters, just like in architectural history, we have a balustrade. We have the nosing, which is the very top of the stair, a shoestring, which runs below the balustrade, a riser, and a tread. And so the riser is our vertical piece and the tread is our horizontal on which we actually put our foot. And when we look at the rise and the run, we're looking at the height of the riser versus the run, which is the depth of the tread. So that's how we figure out how high we want our stairs to be. You'll learn that equation in multiple classes. You'll probably experience it in 108 for sure. I think they've built in the idea of headspace and rules to go along with that into, I think, you can correct me, Heather, or anyone else that's in this class, that's in intro, right? Because I remember the conversation during a jury about the stairs turning and only being allowed in certain places. So do you do the actual equations or do you just kind of guesstimate where they go for that?
You have to do equations.
Yes. Do you really have to? So because I think that was a SHAR class.
I do.
Well, for 108, I know that there was a lot more equations going on, but I thought in
I'm
intro.
a math person, so during intro, I did do the math on it.
Okay.
It made me feel better.
Okay. So Sam says they were given a staircase for intro, at least she was. And so it said how many treads and risers, and then you just figured out where to place it and saw if you had enough height left over for your headspace, pretty much.
Well, they gave you like the stairs, but you had to figure out if there was actually enough headroom upstairs when you did it.
Okay.
Because before they told us the roof, like what the roof was going to look like, people had put it down, and then when they said, "Oh, here's the roof," it's like, "Oh, well, you're going to have like a whole 12 inches to get off the stairs upstairs." So people had to change it.
Okay, gotcha. So, so that'll happen. There is, I'm trying to think what class it's calls or what they've consolidated it into, but the same class that we do the measurements for wallpaper, we used to do that unless they put it into only a materials class at this point. But I know I talk about it in CAD some, not as much in this last CAD group as I did the time before, but it is something you experience. So I've had to design 2 sets of stairs myself and then put the light fixture at the top and make sure there was headspace for it. And the architect eventually would go back, but I mean, it was a good 2 months of me and the architect hoping I did the right thing so he wouldn't have to correct it. So there are things you want to memorize as far as rise over run, but there's also, if you Google stair calculators, they do it for you. And then in SketchUp, it automatically does it. You just have to find an educated source for the stair, and then you can know that it's creating an accurate stair. And in stairs, we're really concerned about comfortable height. So the rise over run being, you know, is it 710? Is it 711? Does it matter differently for certain situations, commercial or residential? But those are the kind of things that are touched on in the book. Winding stair and exit stair, and then ramps. So ramps, we want to consider our landings. We want to think about ramps and curbs and how they work together. Guards and handrails, there's rules for even the thickness of the roundness of a handrail. If it's flat, it's different than if it is round. Stairs and ramps, we want to commit it to memory. So I've put the pages here, 75 through 81. And last semester, I had the students create for points a running cheat sheet of these codes, which I'm not going to do. Instead, I'm just going to have you do the seek and find portion of it. But I'm just telling you, you want to write those down and photocopy them and put them in a folder for your future classes. Building Systems for Interior Designers, Chapter 6, Windows and Doors. So the history of the window and door, they're going to bring you up to speed. They're going to talk a little bit about Egypt and the beginning of man and how we had originally openings, and then we had the invention of glass, and eventually we went from even where we were looking at with our Crystal Palace. We transitioned from iron to steel, so on and so forth, and it brought us to this beautiful window that we're looking at right now. So when we move into our window section, it's going to be a good portion of our homework. We have windows, codes, and standards, window performance, such as National Fenestration Rating Council, U factor, and air leakage. The question marks are supposed to be, we should pay attention to those in our textbook when we're doing our homework later. So how much does the manufacturer say on the sticker that's provided with it, or the info? If you're looking at online, it would usually say click here for dimensions and any more information, which is where you should find, was it approved by the National Fenestration Council? What is the U factor, and what is the air leakage? And actually we want it to be low air leakage, not high air leakage, because it's thinking about how we're preventing it from happening. Window orientations. So that was where we talked about passive design in the earlier chapter, and really I made all the comments on your homework, but that's more what I was looking for is window orientation, building orientation, number of windows, things that weren't active systems like solar or rain collection. I talked with a few people, is kind of a gray area, but mostly I'd still consider that an active, sustainable system. In passive systems, I'm thinking more about climate control through the environment and placement of the building, and then things that are not changing, such as openings that are allowing for heating and cooling to take place. So you'll look at more in-depth window orientations this week. Fenestration is a design and placement of windows in a building. Solar heat gain coefficient, the fraction of solar radiation emitted through a window, both directly transmitted and absorbed and subsequently released inward. And we'll look at products like smart windows and how they control different heat gain coefficients. Light to solar gain, the ratio between the solar heat gain coefficient and visible transmission. So we get a lot of verbiage. These are the kind of things that really add credibility to your homework assignments when I see you using that kind of language in an intelligible way outside of its definition. So fenestration. And this week when I was working with the fenestration of my windows, I mean, how much better does it get than that kind of stuff? Window orientation is in the temperate northern hemisphere. So this is great. We're in the temperate northern hemisphere. And north facing, we have lose radiated heat in all seasons, especially winter. East facing, we're going to gain very rapidly in the summer when sun enters at a very direct angle in the mornings. South facing, it receives low intensity solar heat most of the summer day due to higher angle of the sun. And in the winter, low sun angle provides sun all day long. West facing is going to heat up the building rapidly on summer afternoons, causing overheating and can result in hot bedrooms at night. So they've just really clearly defined for you the northern hemisphere and how we could be placing some of those. The bottom picture isn't really accurate to the concept. I just wanted to have some type of visual, so while I was talking you didn't get completely bored. But what I wanted you to focus on is there's upper windows in a building. Now pretend they're not together. We just have a high upper window in our building, or we have a low window in our building. If you put your windows at the top of your building, you are setting yourself to have a good horizontal amount of light. So like I could have a desk below that I'm hand drafting on, and because they're high up here, I'm getting enough cast light where it's not completely directly on top of me, it's casting at an angle above me in nicely. And then low for vertical. So if I was painting on my canvas and it was set up on a stand in the background and I wanted the vertical light in the room, then I would actually want to put that lower so it's coming more directly in shining at me. Let me check my, okay, I read more of my comments in my chat. Window types, it's going to give you more pictures than this even. I just added some extra ones that weren't in the book, I think. So we have fixed, in swing, bifolding, multi-side, a lift and slide, tilt and turn, outswing, slider, double hung, single hung. People always ask me that question, what's the difference between double hung and single hung? And it's the operation of the window. So single, we're moving one. In double, we can move both the top and bottom down, as opposed to one fixed, one moving up, and a slider is left to right. And here we kind of have like our jealousy or cantilever windows. Casement windows. And then they'll define all of these out for you, but I'm not going to take the time to read them at you right now. Glazing. Glazing materials, glazing and sound transmission, and visible transmittance. So these, again, I think the focus for the homework is on these type of things. And then all of these added charts are going to explain how you can use glazing to your advantage or not. So we have orientation south in the climate, winter heat gain desired, winter heat gain not needed. And then we look at what that means for each of those different climates.
Hey, I have a quick question.
Sure.
Is glazing like a general term for windows, or is it like something you put on a window?
No, yeah, it's a general term for windows. But like the glazing sometimes has multiple pieces to it. So it can be a chamber or it could be an individual piece of glass. Does that make sense? So it could be one sheet of glass. Like if you can imagine, our windows have changed a lot. So they're going to talk about in the book how windows are now made where they have two pieces of glass pressed together, and then they've captured some type of gas in between that to help with certain types of heat issues. So that's still a glazing, but you're right. It has to do with the glass. That's what they're referring to. Heather?
Sorry, I was saying goodnight to my kid. I was listening. I just, like, I don't know, since they call people that cut glass like glazier, how do you say that? Glazier?
Yeah, so glazing is as a verb is the actual, the action of installing windows. So if you look it up, it'll say probably something along the lines of that. But as a noun, it's glass windows, sealed, protective, like glazing.
Okay, so I guess, does it have more than one meaning though? Like, is it glass and glass with stuff on it? I don't know.
So no, I would say we want to think of the glazing as the glass portion of the window, okay? But within that, yes, there are more types of glazing. So like the general category of glazing is the glass of the window, or as a verb, it's to put in a window. But then you could install a sheet of film over that glazing. That causes it to be a glazing with a film on it, or it could be glazing that has a certain amount of gas in between it, like two pressed sheets of glass that becomes a type of glazing. So it's not just one type, if that makes sense.
Okay.
maybe it'll make more sense as we continue to go on. So here, let's go to here. So glazing type, ordinary window glass, right? So we have types of glazing, but they all have to do with the glass. So this is what I'm getting at. So single or double glazed windows, door skylights, transmits solar radiation, absorbs longer waves of IR from interior surface. Or we could have a tinted type of glass, right? Which modifies the view, reduces brightness but not glare. Or we could have a heat absorbing glass, which is gray or brown. So that's where you're saying, are there different materials that added to the glass to do this? Yes, but they're all a type of glass that makes up the glass portion of a window, and that's the glazing.
Okay, so glazing is just glass that you use as a window.
Yes.
In a window.
Yes.
Okay, I'm good with that. Thank you.
You're welcome. Okay, so this chart, when you're thinking about what type of window you want and how you want to control light. There's lots of options. So tinted or colored, or we could just do ordinary and really work on the orientation of our building, or we could do reflective because we're pushing light away from the building. Shatter resistance more has to do with where it's being used. So if there's a water location, like there's lots of rules in residential bathrooms about having certain types of windows near the tub and shower. You have to have shatter resistant glass. Plastic glazing, translucent. So some of these might be big talking points as to why you picked what you picked or would want to pick something this week. Solar heat control window. So this is talking about how the glass goes together. We have the infrared, shorter wave, solar radiation, and a reflective coating that's part of the glazing. Heather, so don't let the picture confuse you. It's showing you that we have like two portions of glass. Clear tinted exterior glass part of the window. And so the reflective coating is helping to control the sun on the exterior. But then on the interior, we want it to let sun in without letting other bad things in. So we have our low E coating, and we have then our clear interior glass. So the coatings are applied to our glazing to make them specific types of glazing. But some are keeping sun out, and some are letting sun in. So from the exterior, we have portions that are keeping it out by doing special things, and on the interior, we have portions that are keeping it in by doing special things with the different materials applied. Exterior shading. Ooh, it's a fuzzy picture. So we're going to go through a couple in following slides, but I just wanted to say that not mentioned in the book very much, and I don't think that it comes in a later chapter, is overhang. I have a huge overhang at my house. It's like the best thing to ever happen because my house is in the 1970s. It's got to be at least a 3.5 foot overhang so I can park my car up next to my house when it rains and get my baby out without putting it in the rain. Even though, like, I have a garage, yes, but there's situations where you just want to pull up right without getting into it. But it does really control light in a special way. And here we just show how that might be on a site. So it's different times controlling it, and sometimes it's allowing it into the space or out, but it's always protecting us from the elements. And then depending on which side of the building, if you get too much direct sunlight at a certain angle, you could add an overhang but have a normal window with no coating, right? So you might combine elements such as an overhang and a window to do what you want to do. And I think overhangs are kind of pretty too in an architectural way. So don't only have to do windows. You might tell me this week, well, I think I'm going to do a window. That's normal, but I'm going to have a special type of overhang, and then I'm going to have a tree that flowers in the summer months, so it's protecting from light too, but in the winter it lends in ample light and warmth, and so on and so forth. How does everything work together? So here's more examples as promised on the last slide. We have horizontal overhang that could protect. We have louvers that can drop. Louvers that it's just louvered from the top. It's not like it goes up or down. It's just slitted. Vertical louvers or fins, east and especially west facades, those are good for. So you could do a basic Google search and say east pointing windows, louvers, and it'll give you the best option. Or you could say west, louvered protection, and it'll give you the best option. Those are the ways that you can use it to your advantage, your searching skills. Find the keywords and put them together. Dynamic glazing systems, so we're getting deeper into the scientific portions. Photochromatic glazing, which changes transparency response to UV light using integral compounds or film. Thermotropic glazing, reflective absorbing or light scattering types change transparency in response to temperature. We have polymer displaced liquid crystal, where electricity applied to a layer of liquid crystals is laminated, assembly aligns or scatters in the light, primarily for internal privacy control. We have suspended particle device, similar to PDLC glazing, electrically conductive glass plastic laminate, can also be used in insulating glass units. So when you're working this week, don't stop at the bare minimum. I'm not going to say it won't meet requirements, but there's so many new vocabulary words, there's so many new options, And I'm not having you do a budget. That's not a part of this project. So I talked with some of you, and maybe not all of you on the, the phone, but a lot of you, about, what am I looking at as far as plausibility of the project versus showing me that you're learning something in my class. So, for instance, Jordan was looking at using windmills near Chicago, and she said she was able to find in her research that there were some existing sites with windmills. But my first thought as a teacher and a person who goes to Chicago is, I haven't seen them, So then it was like, well, is it really plausible? Or is that what matters? What matters is that Jordan understands they're not super popular in Chicago, but there's been some studies on them, and maybe they should be more popular, but they're just not allowed under certain laws right now. So, like, I want to see both sides of the research where she tells me what she's learned about wind turbines and how it works with her building's environment. And then maybe how she covers herself is telling me why they wouldn't be used in Chicago, but it's good to make a regenerative system for her specific project. Does that make sense? Because I think there's been a lot of struggle in the last week between thinking I can only do this because it physically is possible, and thinking this is kind of a conceptually fun project where I have a lot of freedom to show that I've learned about these systems. Just think on it, and if you come up with questions at the end, we'll talk about it. We'll be looking at our new homework assignment in a little bit, so we can cover it more in depth. Window frame types, more for you to think about. Storm windows and screens. Screens actually can be very helpful, protecting against the elements, but also acting as sun control and allowing for more window controls. I know, just opening and closing windows. What I like about this book is it puts things into perspective. I think we take for granted a lot of common day things, like the ability to open and close our windows when it gets hot. We can open them, and when it gets cold, we can close them. This book makes it sound like opening and closing your windows is the best thing since sliced bread. And to be honest, it's pretty awesome. So you might feel, another thing I think students will find when they're doing this, I had a student who said some of these things feel redundant, or some of them feel like everybody knows them, So windows and doors open. We all know that. But what's interesting is the narrative of what that means to the overall environment, okay? What does that mean? So what portion of just being able to control your windows is going to help your energy savings? You know what I mean? No one has really experienced that yet in any other classes. So you might feel like, oh, this is really boring. But in reality, once you tie it into the larger narrative, it becomes exciting, and it shows us that you're a big picture thinker and you can tie it all together. So don't think, if you have a question and you think it's boring, let me know, and then we can spice it up a little bit. I'm really good at spice. Storm window types. Plastic film tape the inside of the window frame. That's my brother's favorite because he's cheap. Interior aluminum frame and 2 sheets of clear glazing film with air layer. Exterior aluminum frame. Exterior wood frame storm windows. Thermal transmission. This is another one that we've kind of covered in previous slides. So when I'm looking at how is this a good pick for my building, we want the window's U factors and R values. We want to see how it's dealing with that solar heat gain coefficient. Is it a high performance Energy Star window? Are there window films you've applied to them? So on and so forth. And if it's not in the book, then do a little bit more research. Any added research, that should be a portion of your study each week. The book's pretty comprehensive, though. I'll give it that. So this just talks about the comparison and what gives you the best R value between the different types of windows, films, glowy coatings, shading and solar control. So again, passive systems, this is what we're thinking of, shading and solar control. Shading, they're talking about all the interior devices and exterior devices. I've shown some of them with the cantilevers that were on the previous slide, the louvers for the window protection. But the interior shading, we have curtains, we have roller shades, we have interior decorative films that can be cut into types of logos. Just really get creative. Or maybe you only need interior because you don't have that much light. I mean, it's not always dramatic. We're not always putting it in the desert. So we function pretty well without some of these fancy things in many of the environments locally. And it is plausible to still have a really good energy system on a dime. But I don't just want you to do it on a dime because it's cheap and easy and you don't have to think about the answer. So it can be expensive or it could be on a dime. I just don't think those need to be the focus. I think the focus is how can I really explore my options? All right, so to give me time to read through your homework, I'm just gonna push through. These are, I think, on the first slide of doors, again, and the PowerPoint I've already uploaded this week, and I uploaded last week's, which I forgot to. So accessibility indoors, 97 through 102, commit to memory. You will never memorize it, but I mean the major ones. We're gonna think about how many inches we have on the pole side, which is 18 inches. We're going to think about 36 inches as the standard best accessible option. All of those kind of measurements, because they'll be in your future testing if you ever want to go on to get accredited. They'll be in your future testing if you go to get your four-year degree. If you want to do LEED, you're going to deal with some of these kind of things. So it's worth looking at and photocopying those pages. And then this has quite a few of them too. So you have my PowerPoint if you want to screenshot it or however you want to save it. And then there's R values for exterior doors as well. And you'll be looking at doors this week. The book does less diligence on explaining doors and special features. I feel like it could talk more about insulated doors and types of doors. But for what it does in this chapter and how small that portion of the homework assignment is, you should have time to kind of research on top of what the book says about doors and make it inspirational, for lack of a better term. Okay. I don't see anything special in my chat. I'm going to go ahead and open up my module 3. So we do have 2B this week for the building codes. And then we also have 3 building components. Now I know you're reading 3 chapters, but really I just covered all the 3 chapters, and I know there's a quiz. I don't know if you noticed, but in the quizzes, most of them where I have multiples like this, when you're taking the quiz, one, I don't think that I did it to do randomized sort, so it should be in order of the chapters. If it's not in order of the chapters, in case it randomized itself, I put a little parentheses at the end of the question and it says 4, 5, or 6. So that way you know at least where the chapter is, although I'm not concerned about the time that you're taking them in, but that way you have a reference and you're not searching for your whole life. So look for those in the parentheses. Assignment 3, if I click on it, it says, read 4, 5, and 6, take quiz number 3 building components, and create the following PowerPoint slides/slides. The slides that show the application of building components should explain a type of construction you plan to use for your structure. And by that, again, I'm being pretty loose about these things, and then I'm giving you feedback. That could be, we looked at, there's type 2, type 1 construction. I'm not super concerned about that, like you figuring out the whole area of our building and its use because you're determining the use. If you want to get to that level of detail, then that would be an excellent, excellent project. If you want to figure out our area and the height of the walls at 10 foot and figure out your occupancy based on what you chose, and then tell me the type of construction and do some fun little codes according to that, you could. But outside of that, I'm really looking for the materials that you're going to use because it's going to help us with our 3D drawings or any type of rendering on plan that we're doing, any type of elevations we're doing, and help with your narrative. So is it going to be concrete masonry? Is it going to be brick? Are you having drywall? Are you having plaster? Is it going to be some type of very special material that's been mentioned that's kind of obscure but will work for this project? A new one that hasn't even been mentioned yet? There's lots of green products out there that are trying to make it to market and have been approved by good organizations but just aren't mentioned in our book. It's a year behind. So you can use new things too and wow me with that information. But mostly I'm looking for materials, and then types is above and beyond. 2 types of windows and how they are sustainable and or will aid the building envelope. So for my people who feel like everything's redundant, let's note that the book itself is redundant, right? It keeps bringing these things up. But in the first week, I was just looking for you to kind of maybe give me an image of a window that you were liking, and then maybe saying, oh, this is an Energy Star window. And just at face value, I Googled sustainable windows. This is the first thing that came up. Now you saw those big lists that were within the tables of possibilities for things we can do to our windows and possibilities for which way it's facing and the styles and types. And then on top of that, I mean, not only do you want it to be sustainable, well rated, well placed, and have lots of benefits, but you want it to look beautiful or at least match the style. And I am giving you flexibility in changing the storefront windows some, so like how you do the mullions or what you might put on that glass. And then the 2 windows on the south side of the building, I don't care how tall, like I don't care about their sill heights. So they could be 2 foot from the ground. They could be floor to ceiling walls that are really thin on that side. So I've given you the scalable PDF, and they have to be that width, but what type of window, I don't care. And then their height, I don't care either. So there's some creative freedom. And then that exterior door could be a real statement piece, just that one door. Do you have overhangs, those kind of things? We want to think about our overall visual that we're creating when we choose our windows and our doors. An interior and exterior door selection. Show pictures of each door and explain why you chose it for this picture. Be specific on the door type, manufacturer, and environmental benefits. If you're in Revit, look for families to bring in that match. So we can draw some things in Revit, but when I'm trying to do a really nice project, I'm sneaky. I'm different than all your other teachers, which you'd learn in time, but I'd look at the model library first. I'd go into Revit and I'd look at doors that way and maybe do sustainable door search in there, and then I would pick, and then I'd find my research from there so that my 3Ds would be how I wanted them to be. So I'm all about that visual. Then it says answer these questions when picking windows and doors. How do the types, locations, construction, thermal properties, and shading of the windows concern the interior designer? What should an interior designer consider when moving, changing a side of window? What do the U factors, R values indicate about the window's performance? How do top lighting and side lighting affect the interior spaces? How do interior doors affect the thermal performance? What are appropriate uses for various types, so on and so forth. So again, these are prompts for you. If you're not going to use them, okay, so it says answer these questions, and there's like 1 through 7. You don't have to if I can see that you can do a well-developed narrative without these prompts. But if you feel more comfortable knowing what you're answering and hitting all of these points, if you hit all of these kind of things in your narrative, you will be assured that you're going in the right direction. But that doesn't mean you have to. There's plenty of other things in those charts that I find very interesting that show me you're picking up on the vocabulary, that show you're coming out of some type of comfort zone and really accepting that this class is a step beyond 108 and beyond intro. We want to see the focus be on environmental. So that's where I don't want to be as easy as pulling the first thing we find on the website for Energy Star. So you can use this. I'm going to give you prompts every week. They might be redundant or repetitive, or you can create your own narrative and try it and maybe ask me before you turn it in, and I'll give you feedback, and then we'll run with it from there. So it says this week's homework is light. I know you guys love that. Now we have 2B, it's not as light as it was when I wrote this. I recommend starting the next week reading if time allows. So then you have more time for the homework assignment next week, but you don't have to. And then that's it. Any questions? 100 questions? Could
For
the,
these PowerPoint
oh, go ahead.
slides, are we adding it into our other PowerPoint, or is this a completely new one that you want?
Yep, you're adding it into your other PowerPoint, Jordan. So it's going to be your final presentation, and then we're just going to tailor it back at the end and cut what we don't want and keep what we do want. But I would say just keep it in one file so it's nice and consolidated.
Okay, great.
Could those windows be a curtain wall, Samantha says. The windows on the south side, like instead of having the wall between them, you just make it another full curtain wall on the south side? Is that the question, Samantha? Sure. I'm okay with that. It's not very much space, so if you want to make that south from the door to the right-hand corner where the 2 windows are, not the whole side of the building, because I want it to predominantly be wall like it is, but from the door to the right side on the south wall, you could make that door and then curtain wall, which means it'd have an L of a curtain wall on that side. Let's see, above. Nope, nothing above Sam. So,
Sound like a stupid question,
love
but
those.
which building core are we using?
All right, Heather. We're using, you had this question last week. All right, so we're in lighting and building systems, right? So that should answer the question. I know you're confused because you're in Revit and you're confusing Revit, but in lighting and building systems, all these files are the same core. So here's the drawing file for the core, an 8.5 by 11 PDF, a 24 by 36 PDF, 11 by 17 PDF. That's just for people to print it off at different sizes, and then it says what scalable size it is based on the print. But if we open up one of those PDFs and we look at it, sure, I'll save you. So this is what Sam was talking about. Sam was saying, this is the core, Heather, and this is the core in your application units that you're building in Revit.
Oh, good.
So that's,
Okay.
so I'm like on top of it, right? I heard Heather cry out and to say, please let there be one teacher for these 2 classes and let her project manage everything in a nice way. So we're building that, and then the hand drafters in this class. So this was what I said for my Revit. We have 2 weeks. By the 14th, we should have all exterior walls done with windows and doors of some type matching up as they are. So this does have to stay storefront or curtain wall or whatever. Basically, all I care about is that it's floor to ceiling pretty much. It's not just a window in the front. And then over here is where I told Sam if she really wants to change these little baby windows to be one of these guys, sure. How do you turn off the drawing file below when you have the building drawn? You can delete it. I believe there's a way to hide it if you really want to hide it, like a layer capability within Revit, but we're not done. So did you draw all the interior stuff too, Karen? Okay, so I'm building it every week. So we have 2 weeks to do all the exterior. And then the reason I didn't say the interior is because in this class, in both classes, for the project, you're allowed to move certain things. So no one can move these walls back here. I'm going to do this, my favorite thing to do, snipping tool. And then I can just write a note that it's here. And you don't have to stay, by the way, guys. If you want to leave, you can leave, and you can just watch it later. I know you have lives. I have one of those too sometimes. So this must stay, okay? It cannot move exactly how it's laid out. We'll just rough in those dry walls. They're like 5.5 or something like that. All the columns must stay. So everything in red is staying at its location. This all has to stay. Okay, now I'm going to take my blue pen. I told Sam, here's 2 windows, here and here. And you could either keep them the width they are, but change if they're floor to ceiling, or if they're 2 foot off the wall to all the way to the top of the ceiling, whatever height you want to do. Or I just gave Sam to do this as all curtain wall if she wants to, like this, or storefront. And it's just a difference in the mullions that are used in the materials, but all I care about is it's just consistently floor to ceiling and the same if you do that. And then your door is what you're choosing, so you only have one exterior door to choose. That's so great about it. What's special about it for this week? Can you walk us through and show us all the windows and doors? Can I show you all the windows and doors? You mean the windows and doors that are in here, like a 3D of this building? Is that what you're talking about, Cindy?
Yes, it's kind of small the way I'm looking at it, so I was just wanting to make sure.
Did that make it a little bit bigger?
Yeah, that helps, yeah.
Okay, so I can do this. I do actually have a model because I just drew it in Revit this week, but it's not on this computer. So actually, let's erase that. Edit, undo, where's my eraser? So if you can imagine, this is the front wall, although not in proportion, right? It's that you have full storefront windows on that front wall. And here's like a person. Well, but this is 10 foot because the highest wall is 10 foot. And so I think that the disconnect is that the Revit people have heard all of this. And I've said it in this class, but I don't think it's been written anywhere. So now it will be said. And then I can put it in writing this week because I feel like there's confusion. But no one's asked me, so fair enough, right? No one's asked me yet. So 10 foot. And then we want maybe a little bit division at the top. But if it was an elevation, just imagine like a boutique where it's predominantly glass, right? And then columns in between. So you can change the material on the front to be anything. It could be brick, it could be plaster, it could be whatever you want it to be. It could be a smart material with special reflective technologies. And these can have mullions, or they could not have mullions. They could have like a special film design on them. They could do whatever you want. The parameter is these are big windows and these were little windows. That's all I cared about. Does that make sense?
Yes. Are there any other windows?
Are there any other windows? Yes. Down here at the front. And the PDF, if you've ever opened it before on your computer, you can always hit Control+. And I have so many sizes that I've given you that are big. But here's the other windows down at the front corner.
Okay, I took drafting, but I guess I'm a little confused on these other areas on the perimeter of the building.
Sure, absolutely. And sometimes I forget that we're all over. Like I have people who are almost graduating and I have people who are just starting. So the perimeter, you want to know what's exterior wall maybe versus what's interior wall. Like this is, I'm just saying ignore it. So let me go back to that other drawing that I had. So I'm going to use my yellow highlighter. So this is all exterior. And why I'm saying only do the exterior for now, so just do like a medium light. Are you doing hand drafting?
Yes.
Okay, so
like what's that right there? Stop right there.
You saw earlier that brick column that was inside the building, so it was that just.
Oh, yes.
It's something like that, but it really, for your project, all you need to know is it bumps out. It could be a drywall bump out, or it could be, it's probably actually brick in this case, but whatever you want it to do. So I'm just giving you flexibility in material. Okay. Just make sure that you draw the lines accurately for the first hand drafting assignment. So draw only the core, ignoring all the interior. So it'd be this whole guy and the bump in. all the bump-ins, even this little notch guy, this whole corner around. And then there's like this weird thing, and my Revit people, because I'm making them learn how to do crazy walls, but like I don't care if you cut it at this first bump and then one across. Like you don't have to draw every notch, but you can if you want to. And then we'll build the wall out to there. But it's all just wall. And then what happened here was it had been this thickness, the yellow, and then the company said they didn't like the notch here because they had some technology people over here. So they just drywalled over it. They added a thickness to even out that notch. But so you could just draw the line across and treat it as one continuous wall in that spot.
Okay.
And then this, and this, and then those guys are windows. So windows are wherever there's a double line to signifying glass. So those three and the two at the front. But you could make the blue one of those if you want to have it be floor to ceiling glass. You could consolidate that whole wall and make it a nice storefront wall.
Okay, that helps. Thank you.
Okay. So 10 foot, and then for the ceilings, if you want to raise the ceilings, you can. I just want like the reason I made it 10 foot only is my Revit people, they'll be learning how to like control three-dimensional properties, and I don't know if they can cut into it by the end of the class and create different heights. So if you as a hand drafter want to do that, I would be okay with that. If you're like, I want to do 12 over a certain area for some reason, as long as the exterior matches that idea, that wherever you do 12, like if it's in the center here, then we would see the change in height in the exterior elevation if you have one, which you might not necessarily ever have one. But you might just have a roof like this, in which you could say maybe at the center in here it's 12 foot as opposed to 10 for a hand drafter. But we'll get into reflected ceiling plans. So we're like in the very basics. I will teach you everything you need to know about how to draw the rest of the drawings. And then inside, we said we had to keep these walls, but where's my removing one? Let me do black. So this can all change. This can change. And I'm going to go ahead and say even all this can change. But you might not want to is the only thing I'm going to say, because it just depends on what your company is. So like existing, like this might be a conference room. This would be a break room. This would be another conference room, storage. And this is utilities and mechanics up here, and a little janitorial closet. So how much of these kind of building core for something small like this would you really want to remove? You know, you can't remove the bathroom either. It's stuck where it is. And so is this kitchenette. You can remove this guy though. Where's this black pen? He's just cabinetry and he doesn't matter, so he can get removed until you have a nice clean coral on the outside. And this guy, I mean, I'm going to say no. Got to keep some weird storage in here. He stays. All right. So 10-foot ceilings. And then you pick all the materials. We keep what's in red. We could change the blue to match the red. And all the black can be moved or deleted as you want. All right, any other questions?
It's just one story, correct?
It is one story.
The exam, yeah. The DW document was 2, and so I'm having trouble with my ceiling. I'll get with you later about that.
The DW document, the drawing file was 2 floors?
Yeah. Yeah.
Weird. Yeah, let's get it together. Can I see your screen, Karen? Is it open?
I'm not on that computer.
Okay. Let me see. Yeah, well, I can open it on here, Project Building Core. So when you open it, oh my lord, lordy lordy. Someone said in the chat, I thought we were doing all the walls this week, so I did the interior walls too. Is that okay? Are we doing anything with the columns this week? Did you do, yeah, we'll do the columns, not this week. Nope, you're not doing anything. And plus there's like so many ways to do the columns, Sam. Like you could have drywalled in a square, or you could use the architectural columns tool, or you could use the non-architectural columns tool. But as long as you follow the rules I just set in place, I'm okay with how far you are. That's no problem. Okay, Project Building Core. Let's try again. It says it doesn't want to open it, but all right. So what are you talking about, Karen? When I go into the existing plan, model space, this is what I see.
Yeah, when I build over top in my Revit,
Mm-hmm.
because it imports this into Revit,
On level 1.
and then it's just a basic plan.
Mm-hmm.
But when I go to put the roof, like draw the exterior, like I would be drafting it,
Mm-hmm.
and then I go to put my roof on, it wants to know if it's the first floor or the second floor.
And
There's no option to pick roof.
No, you don't need an option to pick roof. So a couple people talked to me about this. So when it's asking you level 1 or level 2, it's asking you the ceiling height of the level it's connecting to. So it's actually saying the roof is going to become level 2, right? Because we don't have a second story. So level 1 is everything from the ground up to the top of the wall. So level 1 would be the 10-foot wall and everything on the first level. Level 2 then, if I'm putting a roof on, is the roof. So when it asks you if you want it on level 1 or level 2, you want to put it on level 2 because it's meaning the top of, or the bottom of the next level up, which would be where you want the roof to be because that's the top of the first floor, if that makes sense. So it's asking you if you want it on level 1, where it's going to take the very bottom edge of the roof and put it on the ground because it's building from the bottom up, or it's asking if you want to move it to the top of level 1, very bottom ground level of starting at level 2. So you want to choose level 2, and then it'll put it where it needs to be.
Okay.
But if it placed it already, Karen, you can click on it, and when you click on the roof, it should say in the properties side menu where like the height of it, and if it says level 1, there's a little drop down menu, and you just change it to level 2, and that should correct it.
Okay.
Anybody else? Could be Karen.
But the thicknesses of the walls have to be exact as well, correct?
Correct. I said exact to the interior because we're going to be placing furniture and stuff. If they're like an inch or so off on the exterior, so like as long as when I measure from interior wall to interior, you've placed it so the accuracy is they all snapped to the front interior edge, but maybe the exterior is a little bit off. I mean, it should be fine at corners, but maybe this side is thicker or something by an inch, but the accuracy to the interior has to be correct. So simply put, yes, if you were to do it very accurately and measure each portion, you'd be good as gold. but I'm not going to fight you over an inch on the exterior. If someone got really lazy and was like, oh, I'll just pull it across because it's matching in the front, but it's just coming over this line a little bit. I'm saving my pickiness for reflected ceiling plans and electrical plans. You can only take so much of me being technical. Trust me. All right, any other questions? We're going to close it out. Okay, I will let you guys go.